All right, today we're going to review factoring. So all the different types of factoring, what we learned back in Algebra 1. Let's get started. There we go. So the first one is GCF. This should always be what you look for first, a greatest common factor. So what are both or all three terms divisible by? So it looks like here, these are both divisible by 4, right? 4 and 12. And then we have an x squared and an x, which are both divisible by x. So now we're going to divide out 4x. So if we divide out 4x, we're left with x. And if we divide out 4x, we are left with 3. So this is completely factored. My advice is to distribute and make sure that you have the original. So 4x times x got me 4x squared. 4x times 3 gets me 12x, just to double check yourself in case you made a mistake. Next one, 3 terms, same concept though. We have a 2, a 6, and a 12, also all divisible by 2. We have an x, and an x cubed, so we can take 1x out of all those. A y squared, and a y, we can take 1y out of all those. So we're going to divide by 2xy, we get 1. We're going to divide by 2xy, we get 3y. And we're going to divide by 2xy, and we get 6x squared. Again, distribute and make sure, just double check. 2xy times 1 is 2xy. 2xy times 3y gets me 6xy squared. 2xy times 6x squared gets me 12x cubed y. All right, and again, that is factored. So always look for a GCF first. Always, always, always make that your first step. Now this is factoring when a equals 1. So remember, in a quadratic, your coefficients are a, b, and c. So a is your coefficient of your squared, b is your coefficient of your x, and c is your constant. So when a is 1, notice you just have an x squared up front, right? 1x squared. So this is the easier version of factoring. So we're going to take that number, we're going to take that number off the end, 35. And we want to think of numbers that multiply to 35. So 1 and 35, 5 and 7, and we can actually stop there. So then we want to look at our factors, and we want to say which ones add to 12. Which ones add to 12? So 5 and 7 add to 12. And now we can make our factors. X plus 5, x plus 7. Now you can always, again, you can FOIL this out and check yourself. X times x is x squared. We have x times 7, and then 5 times x, so 7x and 5x add up to 12x. And then 35, right? 7 times 5 is 35. Let's try another one. So we have a 16. 1 times 16, 2 times 8, 4 times 4, and we can stop. Now we want to know which ones add to 10. Well, 2 and 8 add to 10. Now, be careful, because it's not just your old ordinary 10, it's a negative 10. So a negative 2 and a negative 8, negative 2 times negative 8 makes positive 16. And negative 2 plus negative 8 gets you negative 10. So be careful with positives and negatives here. Make sure it multiplies to get you this and adds to get you this. So we have x minus 2 and x minus 8. X times x is x squared. We have negative 8x and negative 2x makes negative 10x. And then negative 2 times negative 8 is positive 16. So just checking ourselves as we go back. Next one, we have a negative 8. So what numbers? Let's just do multiplies to 8 first. So 1 and 8, 2 and 4. Looks like that's it. So which one of those subtract to get me 7? Well, 8 minus 1 is 7, so we're going to look at this pair. Now, you know one of them has to be negative to multiply to get a negative 8. We want it to be negative 7. So negative 8 plus 1 gets me negative 7. Negative 8 times 1 gets me negative 8. So you always want to go back and check. Multiply, you should get negative 8. Add them, you should get negative 7. And now we can do our factors. X plus 1, x minus 8. Alright, so that is factoring when a equals 1. And now moving on to factoring when a is greater than 1. So when you actually have a coefficient to your x squared term. So notice here 8x squared. So this is called the AC method. AC method. And why do they call it the AC method? Well, your first step is going to be to multiply A times C. That's why they call it the AC method. So 8 times negative 3 gets me negative 24. So what multiplies to get me negative? Well, we'll worry about the negative in a minute. 1 and 24, 2 and 12, 3 and 8, 4 and 6. I think we can stop there. So we know one of them has to be positive and one of them has to be negative. We want to get a positive 2. So how about 4 and 6? All right, 6 minus 4 gets me positive 2. So again, always go back and double check yourself. 6 times negative 4 is negative 24, and 6 plus negative 4 is 2, or 6 minus 4 is 2. So now what makes this different? So we're not just going to say x minus 4, x plus 6. The way I do it, and it may be different from the way you've learned it or other teachers do it, if you have a way that works for you, please use it. I'm just giving you another tool if you might not have a good grasp on the AC method. So I always take whatever's in front of your squared, 8x, and we're going to write it twice. We're going to make some fractions. All right, what goes in the bottom? All those two factors that you just found. And now we're going to simplify our fractions. So it looks like this one's both divisible by 4. So divide by 4, you get 2x. Divide by 4, you get negative 1. And that is simplified. Here, these are both divisible by 2. Divide by 2, you get 4x. Divide by 2, you get 3. And once you're simplified, you have your two factors. So we have a 2x minus 1. And we have a 4x and a positive 3. I highly, highly, highly recommend checking your work, even if it's just a mental check. 2x times 4x is 8x squared. We have 6x minus 4x leaves me at 2x. And then negative 1 times 3 is negative 3. So it just takes a quick spot check. Make sure that it works. All right, let's do the next one, AC. So 18 times 2 is 36. So what do we got? 1 and 36, 2 and 18, 3 and 12. I feel like we can stop. We want ones that add to 15. So 3 and 12 looks beautiful. All right, so we're going to take whatever's in front of our x squared. Oops, in front of our squared. So we have 18x, 18x, write it twice. 3 in the bottom of one of them, 12 in the other. So 18 and 3 are both divisible by 3, so we got 6x, and then divide by 3, you get 1. These are both divisible by 6, so we get 3x and 2. And once you're simplified down, we have a 6x plus 1, and we have a 3x plus 2. Again, go back and check your work. 6x times 3x is 18x squared. We have 12x plus 3x gets me 15x, and then 1 times 2 is 2. Now you might say, Ms. Blake, why is it different? Why do we do something different when a is bigger? Well, we actually don't. So if I actually back up to the last one. In these examples, A is 1. That's why you can just look at C. 1 times 35 is still 35. So nothing's really changing. And you might say, but there's no fractions here. There is, right? There's an x. So really you have an x, and we're putting a 5 and a 7. So there's just no simplifying those fractions. They're already simple. So we did technically use the AC method here. You're technically always using the AC method. It's just sometimes it's a little bit harder. So here you don't necessarily have to use the AC method straight out. You can kind of shortcut it for yourself. But we did use the AC method there. All right, the next one. Now, before I start this problem, I'm looking at these numbers. They're huge. But I noticed they're all divisible by 2. They have a GCF. We're going to pull that GCF out. So make your life easier, and you do have to take that as a first step. So your first step should always be, can I factor out a GCF? Now we're going to work in here. 5 times negative 12 is negative 60. We got 1 and 60, 2 and 20, 30. Don't check my math. There we go. 3 and 20, 4 and 15, and I think we can stop. It's a 15, by the way. So we want negative 11, right? Negative 11. So it looks like 4 and 15 subtract to 11. We want 4 minus 15 to get a negative 11. And then we're going to take that 5x and write it twice. We get a 4 and a negative 15. So that one's done. Here, these are both divisible by 5, so we get x, and we get negative 3. So here we go. Don't forget that 2 up front. Actually, I'm going to write it right here, 2. And then we have a 5x plus 4 and an x minus 3. All right, moving on. Difference of squares, everybody forgets these. Difference means subtraction. It has to be subtractions. And perfect squares. So x times x, 4 times 4, 10 times 10, 3 times 3, right? Perfect squares. So difference of squares, we got x squared would be x times x. 16 would be 4 times 4. 1 becomes plus, 1 becomes minus. And notice there's no x term because you'll have negative 4x plus 4x. It'll cancel out. Let's do the next one. 25x squared would be 5x times 5x. 100 would be 10 times 10. 1 is plus, 1 is minus. Again, the plus and the minus cancels out those x terms. So you do have a negative 50x and a positive 50x, but they cancel each other out. That's what's so nice about difference of squares. So difference of two perfect squares. Difference, subtraction, perfect squares. Let's do the last one. 49x squared would be 7x times 7x. And 9 would be 3 times 3. 1 gets a plus, 1 gets a minus. And I think that's it. All right, get your work done. Bye, guys.